Now the review section on 0.2 is on fractions. So first thing we're going to start with is how to reduce fractions. Okay, let's say I have something like this, 47 over 78. Like, reducing means I want to write this fraction as an equivalent fraction where the numbers are the smallest as possible, smallest integer as possible. Okay, now see 42 and 78, those are both even numbers, so they're both divisible by 2. So I could divide the top part by 2, divide the bottom part by 2, and because I'm doing the same operation above and below, their ratio is going to remain the same. So that's going to give us 21 over 39. Now I could think, well, okay, those are those still even numbers, but they're not. They're both odd actually. So maybe I can try to see if there's another number that fits into both of them. And then it's not 2, but maybe 3. So how do I know if 3 fits into 21 and 39? There's a trick to see if a number is a multiple of 3. If the, for example, take 21. If its digits added up give you if it gives you a number that's divisible by 3, then the original number 21 is divisible by 3. So in fact, now we know that 21 is 7 times 3, so we can also divide 21 by 3. I didn't check if 39 can be divided by 3, otherwise that would be useless. Well, let's look at 39. 39, if I do 3 plus 9, that's 12. Oh yeah, that's a multiple of 3. So 39 must be a multiple of 3. In fact, 39 is 3 times 13. So that's going to give me 7 over 13. And those are both prime numbers. I recognize them. So I can't divide any of them by another number besides 1, which would be useless. So this is the most reduced form of my original fraction. Of course, if I know my multiplication table very well, if I'd have divided by 2 and by 3, it's because I could have originally divided both numbers by 6. Okay, but sometimes it's hard to see that. So I usually recommend, well, start dividing by small numbers like 2, 3, 4, 5, okay? And just keep on moving and repeat. So if you've divided by 2, check if you can divide by 2 again. That means, of course, you could have divided by 4, but sometimes even by 4 you don't see it immediately, or you're not careless, but you're lazy. You say, oh, those are 2 even numbers, I'll just start dividing by 2 first. Well, that's completely fine, as long as you keep looking if you can divide by 2, and when you can't, move on to the next number, 3, and then the next. You just have to move on to the next prime number, by the way, right? If you've divided by 2 and it doesn't work anymore, don't try to divide by 4, because if you can divide by 4, it's because you can divide by 2. So that's why we're only going to look at division by the prime numbers. So what are the prime numbers? 2, 3, 5, 7, 11. Okay, usually that's enough to reduce your fractions as far as the sort of numbers we're going to be considering in this course. Multiplication. Okay, if I do something like 4 times a half, what does that mean? Well, that means that I'm doing 1/2 of 4. If you're not convinced of this, okay, that mystery number we're looking for, if I multiply both sides by 2, it's as if I'm sending the 2 on the other side, so it means 4 times 1 will be 2 times the number I'm looking for. So clearly that number I'm looking for, that's half of 4. Okay, So what's the half of 4? Well, that's 2, right? Okay. Another way to see it is 4 times a half. That's also 1/2 plus a half plus a half plus a half. So how many halves do I have? I have 4, and 4/2 is 2, right? If I have 1/2, 2/2, 3/2, 4/2, overall I have 1 plus 1, I have 2. So that just shows that what I can do when I multiply an integer by a fraction is I can multiply the 4 with the 1 and then divide by 2. That's the exact same thing, right? So often we'll do this. So when we'll see something like this, 4 times a half, I will just write 4 times 1 over 2, 4 times 1, 4, divided by 2, and then I will reduce this fraction. I can divide both numbers by 2, so I get 2 over 1, and 2 over 1 is just the same as 2. Let's see something maybe a bit more complicated. 4 times 3/2, well, that's the same principle here. It's 3/2 plus 3/2 plus 3/2 plus 3/2. Now those are all fractions that have the same denominator, so I can just add the numerators. So if I add those numerators, how many 3's do I have? I have 4 of them, which I divide by 2. So it shows me that, once again, I can multiply the 4 with the 3 first, and then divide by 2. So I can say, well, 4 times 3, that's 12, divided by 2. Those are 2 even numbers, so I can divide by 2. 12 divided by 2 is 6, 2 divided by 2 is 1. So that's just 6. I could also maybe be smart here. Here's the smart thing to do. If you do 4 times 3 over 2, you can also say, oh, that's the same as 4/2 times 3. And then regrouping those two together was smart because I know those are 2 even numbers. So maybe instead of reducing the final answer, try to reduce along the way. So 4 over 2, I can reduce that to 2, and then I just do 2 times 3, 6. So that would actually be the best solution. So if I read the solution like this, this is equal to this, which is equal to this. That's the best possible solution. Let's do another one. 4 over 7 times 3/2. Okay, now I'm going to be smart here. Okay, so that's, according to what I see up there, I could say this is the same as 4 times 3 over 7 times 2. If you're not too convinced, well, 4 over 7, that's 4 times 1 over 7 times 3/2, okay? Now remember, these two I can, using a previous rule, I could say this is 1 times 3 divided by 7 times 2. And if I do times 4, well, that's going to be 4 times 1 times 3 over 7 times 2. So you see, I do get this thing here. Okay, so when I have fractions multiplied together, I can just multiply the numerator and multiply the denominator. Warning. Okay, once we see that rule, students start applying this rule to addition, and that's not going to work with addition. Okay, so if I do this, that's not 4 plus 3 over 7 plus 2. Okay, so that's a big no. So what I just said only works if you have a multiplication. So 4 over 7 times 3/2, yes, you can multiply the numerator, multiply the denominator. But only if it's a multiplication. Now afterwards, I could of course multiply 4 with 3 and 7 with 2 and then reduce. But let's be smart. Let's try to reduce along the way. I can see that 4 and 2, oh, I could simplify those. So maybe regroup those together. Okay. So usually that's, well, when you're going to be experienced, this is going to be a step you're going to do in your head. You're going to regroup virtually in your head the 4 with the 2. And say, oh, 4 over 2, that's 2. And then times 3 over 7. And now it's automatically reduced because I know 3 and 7 can't be reduced, and And that's it. That's my final answer, 6 over 7. Division. So if I have 4 divided by a half, what does that mean? It means how much does a half fit into 4? Okay, let's think about this. I've got 4 pies, and I want to see how many halves are there in these 4 pies. I can count them. 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8. So what I can actually see is that this is exactly the same as doing 4 times 2. And it's not a coincidence, okay? So when we divide by a fraction, it's the same as multiplying by what we call the reciprocal. Reciprocal is when we flip the role of the numerator and the denominator. Okay, so let's see that with something slightly more complicated. If I have 8 divided by 6 over 7, that's the same thing as 8 multiplied by the reciprocal, 7 over 6. Once again, let's be smart about this. 8 over 6, oh, I can reduce that. This is 4 times 7 over 3. Can I reduce anything else? No, the 3 doesn't go into 7 over 4, so that's going to be my final answer. It's reduced. You see, that's I find easier than doing 56 over 6 and starting and then reduce afterwards, especially if the numbers are big, and if you've got many things multiplied together, you're going to end up with very large numbers. So if you start reducing just at the very end, it's going to take you some time. So don't do that. Reduce along the way. If I have minus 8/3 divided by 6 over 7, same idea. This is minus 8/3 times 7 over 6. Notice that eventually it's preferable to use this symbol for multiplication because the x will be used in this course for something called a variable, so I'm not gonna usually use the x for multiplication. So here, what can I do? Once again, I can reduce 8 over 6, that's that's 4/3, and then 3 doesn't go into 4 and 4, so I get minus 28 over 9. Adding and subtracting. How does that go? If I have something like 8/3 plus 6 over 7, now I can't add the numerators and denominators because it doesn't work this way for when we add things. What we have to do to be able to add fractions is to have common denominators, and those are not common. It's 3 and 7 are completely different. Okay, so what we are going to do is find to find a common denominator. We're going to find what's called the least common denominator of the two fractions, 1/3 and 1/7. Which I like to call the least common multiple of 3 and 7. So we're going to find the least common multiple of 3 and 7. Actually, the book calls also that the least common denominator of 3 and 7, but I find that strange because there are no denominators when you talk about only 3 and 7. So so here our goal is find the least common multiple of 3 and 7. That's the same thing as the least common denominator of 1/3 and 1 over 7. So we want to find a number which is such that 3 and 7 fits into it, and that's the smallest as possible. So there's a candidate that you can obtain that where you're going to be able to fit 3 and 7. It's 21 when you multiply them together, but there's no guarantee that when you multiply the numbers together that you find the smallest. Usually we want to find the smallest. Here it turns out that 21 is the smallest, but it may not be so all the time. So if I have 3 and 6, you see, if I multiply them I get 18, but that's not the smallest number that where you can fit 3 and 6 into it. You can actually fit 3 and 6 into 6. So 6 is the least common multiple of 3 and 6. So 6 would be a much better choice because it gives you something smaller to work with. Okay, so how do we find that number here, 6 or 21? The recipe is pretty simple. You take the largest of the two numbers. So let's say 3 and 7, you'd pick 7. 3 and 6, you'd pick 6. And you look at the multiples of that number. Okay, so what are the multiples of 7, for instance? Well, 7, 14, 21, 20, and so on. And for each multiple, try to look if 3 fits into it. So does 3 fit into 7? No. Does 3 fit into, what's the next multiple of 7? 14? 3 fits into 14? No. Does 3 fit into 21? Yes. Okay. And you could do the same with 3 and 6. Does 3 fit into 6? Yes. So it's 6. See, I'm done right away. So here I'm going to be using common denominators and usually the smallest common denominator possible. So if I want this 3 to become a 21, that's because I need to multiply it by 7. I need to multiply that by 7 as well so that things remain the same. So remember, if I do something to the denominator, I need to do the same thing to the numerator to preserve equality. So 8 times 7, 56. And here I need to multiply both numbers by 3. And now I have common denominators, 21 and 21. Now I can add the numerator. That's possible now. So 56 plus 18, so that's 74. And that's my final answer. If I do maybe another example, if I do 1/6 minus 1/4, well, here I'm working with 6 and 4. I need to find a common denominator, least common denominator. So pick the largest of 6 and 4. So that's 6. Look at the multiples of 6. And so first multiple 6. Can you fit 4 into 6? No. Look at the next one. 6, 12. Can you fit 4 into 12? Yes. Oh, so it's 12. So we're going to put everything over 12. So 6 times 2 gives me 12, right? So I need to multiply the top part by 2, and 4 times 3 gives me 12. So I need to multiply everything by 3. So 2 minus 3 minus 1 over 12. And that's my final answer. Notice I can write it as minus 1 over 12 like that, or I could also write it as minus 1 over 12. And that's identical. It's the same number. Usually we will write our fractions like this, with the minus sign sticking in front.